Okay, I think we can go ahead and get started. Hello, everybody. My name is Jeffro. I'm the program manager for LF Energy. I want to thank you all for coming to this webinar series. This is the fourth webinar in our series on the technical projects within LF Energy. And I just wanted to introduce the webinar and to let everybody know there is a chat window that you can use to get in touch with me if needed. There will also be a Q&A window available. If you scroll to the bottom of your screen, you should be able to see a Q&A box. You can ask questions there, and I will make sure that the presenters are able to see them and answer them. And it looks like we've got a few more people showing up. So let's go ahead and get started. What I'm going to do is do a quick introduction on LF Energy, and then hand it off to Jean-Baptiste and Anne. So actually, if you guys want to run the slides, that would probably be the easiest thing. If you want to advance to the next slide, it'd be great. So this is a picture of the internet. Shuli, our executive director, likes to start out the conversation with this slide because it is a really fascinating map of all of the different nodes on the internet at some particular time. And it's interesting to note that while this did grow essentially organically, it was also grown using largely open source principles and a set of design principles to enable it to scale to the degree that it is. And we all know that there are billions of nodes on the internet at this point. The whole concept of LF Energy and the goal is that we need to leverage the same design principles that we used to scale the internet, the entire worldwide network, to build out the energy grid and to create an global interconnected energy grid in the same way. This is called the energy transformation, and it is underway right now. And I think that one of the most important aspects of it is that it not happen in silos or by individual companies driving it. The really important part is that we all work together to do it, and that is one of the open source principles that the project operates on. Can we go to the next slide, please? The idea is to leverage the world's largest shared technology investment, which is the open source software world. Linux Foundation is at the heart of this. The Linux Foundation guides the Linux project and provides its funding. And it manages almost 200 open source projects at this point. They're all in various stages of their evolutionary development, but the one thing that they all share is that they all work together. It is all groups of people working together, very often people who are competing with each other. And that creates a very powerful ecosystem in which people's needs do get met because everybody's at the same table. Next slide, please. So the mission of LF Energy is to build the grid of the future, which we see as being composed of loosely coupled systems that are resilient, manageable, and observable. And those are all very important adjectives. We need to build out robust automation in order to be able to manage this kind of global interconnected system. And it needs to be resilient. It needs to be observable. Being able to see things is actually the basis of many of the projects that are currently within LF Energy. And the end result of this, that was what we hope, is that it will accelerate the energy transition by fostering these principles of open source and to create vendor-neutral projects that everybody can benefit from and create a democratic system. Next slide, please. The need for safe, shared, scalable code, I think for anybody who's been involved with open source for a while, these seem like obvious things. That to make code scalable, it needs to be safe and shared. And in order for it to be safe, it needs to be able to be shared, and it needs to be scalable. These are all interconnected ideas. most industries today run primarily on open source modules, and that's a bold statement, but it is absolutely true. One thing that I like to usually pull out during talks like this is to just give some thought to how many different computers there are between me presenting this and these slides being presented in France and you watching from wherever in the world you are, and how many of the machines in between are all running open source software. With the global internet and all of the different telecommunications systems in between, it's in excess of 75%. So if there are 30 machines between us, for example, that means that probably 24 of them are running open source software. Open source supports business agility while preserving intellectual property. And that's very important for organizations that want to join these projects and help develop them, that they know that they will be able to preserve their intellectual property and their business value going into it. Next slide. This is a map of the current projects within LF Energy, transposed over a map of the way that we see the energy market and the energy world, with markets up at the top, because the markets, of course, that's where the money is and that's what drives everything. The EM2 project and OpenEE meter are tightly involved with flexibility and energy efficiency and measuring that and figuring out ways to measure that. Operator Fabric is for control room operation within so the TSOs and DSOs are very interested in this. Remote orchestration and distribution and control. REAPS is a really interesting project that is at the heart of that. What we're learning about today is PowSyBl with planning, design, and simulation. And you can see all of the other opportunities out there. We see each of these blocks as being an opportunity. One project that's spinning up that's very interesting right now is OEDI down at the bottom. It's a very large project that's being run from the US National Renewable Energy Lab, all around open data. So there's all of these projects are very interesting. There are other projects that are forming now, and we encourage you to jump in and participate, join the mailing lists. We'll have links at the end, and with that, I would like to introduce Jean-Baptiste and Anne, who will tell us all about PowSyBl. Oh, I do want to also cover our founding members. This is the current lineup of members within LF Energy. Anne and Jean-Baptiste are both from RTE. So let's talk about PowSyBl.
So hello everyone. So you can call me JB if you prefer. It's shorter and I guess easier to get in memory. So I will talk about PowSyBl today. So you can go to next slide. So before talking about PowSyBl, it's to talk about the motivation to start this project. So some of you might know that this project started with a European project where we try to design the future of the security analysis tools for the next generations. But here it was focused on the coordination in Europe. And we saw from that we wanted to push new things, but it was not possible to do it with standard tools. So the issue was to be able to push for new functionalities, but in the meantime, having a way of maturity of the tool that is quite good, because we needed to test intensive computation, and for that, it was not possible to do it in MATLAB or some tools that are not designed for industrial purposes. So here are the difficulty and the points, the key point of the why we did and we started with PowSyBl. It's to have in the meantime the flexibility to design new tools, because the operators and the user have new and increasingly complex needs. And in the meantime, we wanted to keep maturity and the robustness of the tool that we are using. So this sounds like a contradiction. And the idea of the project of of PowSyBl is to reconcile this contradiction. So we can switch to the next slide. The general overview, PowSyBl, what does it mean? It means power system blocks. So from this name, you can guess that we are talking about something close to the Lego, but applied to power systems and the way to make and design and build tools for power systems based on the same principles as Lego. So the idea was to make it easy to write new tools and to answer the new needs and the growing needs, especially in the energy transition, and to be able to extend it and to make it evolve very fastly and easily, depending on the needs that are maybe unknown today. So that's the general overview. And now we will go and focus in the details of what is possible. But first, I would like to recall that PowSyBl is licensed into the MPL v2 license and hosted in GitHub. So of course, you can already now access to the sources of PowSyBl. And now we have 40 people involved in the community of PowSyBl, but we expect that it will grow soon. So if we make a focus on PowSyBl, what is exactly PowSyBl, concretely speaking? So it's a set of modular blocks. So you can see them like the little pictures on the right of the slide. So you have capacity of importing and exporting data. You have some blocks related to processing of the grids, like extraction of some part of the grids, merging grids. You have the capability to define contingencies, the capability to define remedial actions, and then you have the capability to launch security analysis and load flow. So you can see that all these pieces of functionality are isolated, but then if you want to build a new tool, you can assemble them together so that you can have a new tool. For example, if you want to run security analysis, it's very simple. You just need to bind a data importer to import the data in a certain format. Then you can run a load flow. Based on that, you can define a set of contingency and then rerun a load flow to have a post-contingency state and see what are the constraints on the grid. So it's very simple, and all these bricks are already available. It's just a matter to assemble them together. So now if we focus on the functionality and what is contained in PowSyBl, so first, of course, we need to have a set of classes that is able to define and describe the grid. So the line, all the equipments, the lines, the transformers, the generators, the loads, HVDC, etc. So we need to have all the classes of equipment being able to describe a network and being able to run a full study, including all those equipments. And the issue, this is true for all the tools that are designed to make studies on the grid like this. But the specificity is that here we are learning from the past, where we try to put everything in this set of classes, and the model, the internal model, was just growing and growing, and then in the end it was very difficult to keep it in a way that is understandable by everyone. So here we decide to keep a core of classes and then to use the possibility to have some extensions to add some very specific components for some specific needs. For example, if you want to make a study on a grid, but you want to make a link with power to gas, for example, you can, for example, decide to make an extension related to power to gas and then plug it to the core of those set of classes. This way, not everyone will be obliged to use the power to gas extension, but only people who are interested in that. So that's the main idea of extensions of PowSyBl, and to keep the core really based on the core activity of power systems. Then you have some services on that. You have different ways to view the topology. So for the people who are familiar with the power studies, you have different ways to describe the visualization of the grid. You have a node breaker, which is a detailed one with all the circuit breaker, etc. Then you have a second view that is more aggregated. You have the buses and the breaker, so you can just modify the number of nodes, but you are already in a nodal view, and then you have a bus branch one, which is the most simplified. Of course, from the most detailed view, you can deduce a more aggregated one. But of course, in the other side, it's not in the other way, it's not possible. But you have those different topological views that are aimed for the different needs that people might have. We have a topological merge option where you can bind together grids from different regions. So for example, this was made here for European coordination when we want to merge a French grid with a Spanish grid. Then you have a view, a complete view, an aggregated view of the grid on which you can make a pan-European security analysis. So this is an example on how we can use the topological merge. Then you can have network extraction if you want to focus more on some specific area. And so you have many ways to define your extraction. So now we can switch to other features. So today there are two formats that are supported in import-export. So the export of the UCT format is available soon. So UCT and SYN-CGMES are formats that are more centralized around the European coordination. So of course, if people want to create a new import or export from other standard formats, it's possible. But today we focused on the European coordination, and CGMES and UCT are today the most used format for European coordination. Then, yeah. We have also many simulators that are already integrated in the framework. So because, of course, if you don't have computation modules, then you won't be able to do anything. So, of course, we need different types of simulators. We have the load flows. Today, we have a simple load flow that is open source, but this is not the official load flow that we are using at RTE. We will talk it in the next slide. We have optimal power flows that are open source metrics. It's a DC approximation. And we have also dynamic simulator, DynaWo, who will be open source by the end of 2019. We have also APIs to launch computation on security analysis, but it has to be plugged with a load flow able to make this computation. And we have also sensitivity computation. We have only the APIs, and we have to connect it with a sensitivity computer. Then here you have the modules that are not open source. So the load flow that is used officially at RTE is ADES2. It's a freeware. And we have also N that is developed by a private company, a Spanish company. Of course, here you can see that not all the load flows are open source, and maybe for some people this sounds like something not satisfactory. And of course, the idea of PowSyBl is to open the competition, to plug more and more computation modules and to compare the result. And it's just a way to, as I said, to open the competition on the computation modules. And the more we have, and the better it is. And then people will have the choice between closed or open computation modules. So we just start the move, but of course we expect to have a richer panel of computation modules. Then we have also other modules that are based on ADES2. So we have a security analysis and a sensitivity analysis, but ADES is a freeware and is available on the website. You can download the executable. And then we have also some optimizers that are based on the MPL language. So last slide for me. So we have also some features related to HPC. So the capability to distribute computation. This was started during the R&D project, R&D project we made, and this is still available. And I know that many people need to make a lot of parallel computation sometimes with many load flows to make large security analysis when it comes to a probabilistic approach. So this is a capability of PowSyBl. And then we have also some feature to store some studies for people and to share them with other partners. So that's mainly it about the features of PowSyBl. I will give the floor to Anne.
Hello, everybody. My name is Anne. I'm working on PowSyBl project, and I'm going to give you some statistics about the code. So for the moment, PowSyBl, it is 78% of test coverage, including the Groovy code coverage, because we have some Groovy inside the Java code. And some statistics about contribution. For the moment, the community is about 40 contributors in the community, 2 new people since a week. We have around 300 feature commits on PowSyBl core last year. By feature commit, I mean it's like a pull request because our commits are more than 500 lines of code. And for the moment in PowSyBl core, we have about 80,000 logical lines of code in Java. So now I'm going to make 3 demos. So I'm going to explain the user story, and this user story will be declined in 3 demos. So the user stories can concern transmission system operators or regional security coordinators. They made it every day, every hour, in order to detect security violations before and after contingencies. So I'm going to show you a really simple workflow. So first we will import the RT network, which is stored in CGMS format. It is a case from January this year. And then we are going to compute a security analysis. The list of contingencies is a bit short. It's just that we are going to simulate the loss of 2 lines. The 2 lines are 2 400 kV lines between in the south of France, between the Tavel voltage level and the Realtor Tavel voltage level. And there are, we use these big lines to give electricity to a sub area in the south of France, around Marseille. So I'm going first to use our graphical interface demonstrator. Then I'm going to use a command line tool, and then I'm going to show you some lines of code. So here we have our grid study environment, which is our demo tool. You can see here the French network. Here you have Paris. We are here actually with Jean-Baptiste. And I'm going to simulate a contingency in the south of France between this voltage level and this one. So you see the red line, it's a 400 kV line, and I'm going to write this contingency to the software. So I need to explore the network. So it's going to load all the CGMS data. So now I'm going to find the realtor voltage level. So it's here 7 means 400 kV, so it's this one. And here you can see the two lines. So we can move this here, and you just have to drag and drop like this. And then the other lines here. It's better to rename the contingency because it's a contingency of the loss of 2 lines. Here we have the contingency list. Then I'm going to create a security analysis. I need a case file, which is a network, in fact, and I need a contingency list. And it's a list I have here. And you can then run a security analysis like this. And we can show the results. Here you have the pre-contingency. It means that it is a violation you have on the state before the loss of the 2 lines. And here you have the contingencies after the constraint, the violation, sorry, after the loss of the 2 lines. In fact, you can, here you can see, sorry. So it's it's parameterable. You can see the voltage level violation. You can see the overloaded violation, and you can also see the short circuit violation. I have put all them, and here we can see that we have 4 lines in constraints. So we are going to sorry. So here we can see that Bol mean Bolen. It is a city here in the south of France. Here. And then you have Terra mean this voltage level. So it is this line which is in constraint. Then we have a line between this voltage level here. We can zoom. Here you have the RT voltage level. And the other voltage level is here, so it means that this light is in constraint. Then we have also a part to here, and we have a line here. So it's clear that when you don't have this way, the electricity has to go here, and we made some constraints. So it is our demo tool, and in an industrial application, for sure, we will have some indication in the map to see the constraints. So now I'm going to show you the same workflow with our iTools tool. So here it is the CGMS file. So for and here is the contingency file with the 2 lines. So I'm just going to use the security analysis mode of our iTools. And then I need to put the path to the case file. And the path to the contingency file. So you have here the import of the CGMS file. And then here you can see exactly the same results as before. So we have the 4 equipment in constraints. And that's all for the iTools demo. And then the last demo is with some line of code. So with the pictures presented before, here you have the import gateway. So you have to declare the path to the CGMS file. Then you ask to an importer to load the network. So it's the last line. This is a Java code. And then here you have to write a contingencies provider. A contingency provider give you in return a list of contingency, which are in fact the line between 2 voltage levels, Tavel and Realtor. I put it the both in the same contingency, and I have my list. And then once my contingency list is declared, I have to write a security analysis factory. So for that I need a network, as I had before. I also need a computation manager, because as Jean-Baptiste explained you before, we can make a local computation, and we can also make parallel computation. This here it's quite simple, so it remains local. I also need a security analysis parameter, and I'm going to use a default one. And the last line is to run a security analysis. So I'm going to run it on the network with the default parameters and with the contingencies provider I have declared before. So that's all for the 3 demos. To conclude, I want to say some words about contributing to PowSyBl. So we use a feature branch workflow, and if you want to make a new feature, you have to develop it in a dedicated branch, and it is merged in the master branch only if the branch compiles successfully on Linux and on Windows. Mac is coming soon. If all the unit tests passed successfully, if all the quality checks passed successfully, by quality check, I mean code quality, code coverage, code style, and since several months, the developer certificate of origin. We hope at least 2 successful reviews. And in our community, any contributor can review a pull request. And finally, the merge is done by one of our 8 committers. If you want more details, do not hesitate to refer to our contributing on GitHub. And finally, the most important is do not hesitate to join us on Spectrum and to get in touch with the community. So that's all for us for our presentation. If you have some question, we will answer it.
Looks like there's one question that has come up. Michelle asks, what are PowSyBl's main advantages compared to other open source solutions, such as PandaPower, PyPSA, GridCal, and others listed on OpenMod? Is it mostly the integration to the other tools supported by LF Energy?
So we know not that much about the other initiatives. We know about PandaPower. So what we can say is that PandaPower is mainly focused on the Python approach. So from our view, the difference is that this PandaPower would be suitable mainly for research, because we have some people internally at RT who are making some research, and Python is more adapted for specific needs. So for that, they are using PandaPower. Whereas in PowSyBl, we are more focusing on something that is with some industrial maturity to be able to make it online in dispatching. And so that's the main difference. We aim that most of the tools that we are building on PowSyBl will run and assess the security of the grid in real time. And today we are already have some tools running at RT using PowSyBl for security analysis. So I would say this is the main objective of PowSyBl is the capacity to be flexible but with some industrial maturity.
Okay, thank you. We're open for any other questions that people might have. You can also feel free to join the mailing list on lists.lfenergy.org in order to ask questions there for PowSyBl or for any of the other LF Energy projects. So it looks like we don't have any further questions coming in from the audience. I'll give people another few seconds here. But in the meantime, I guess we can just go ahead and wrap up. Really are very grateful for JB and Anne for giving this today. The video for this will be available later on today or tomorrow. It'll be on the YouTube channel for LF Energy, as well as listed from the website. Again, we want to encourage people to go to lfenergy.org to learn more about the project. Go to lists.lfenergy.org to join the mailing lists and learn more about each individual project, and to keep up with it, and to encourage people to participate as much as possible. So with that, I think we will go ahead and wrap up. Any further questions, please contact us on the mailing list, and we will see you in 2 days for the next webinar. Thank you very much.
Thank you.
Thank you.